In this video tutorial, I will introduce you to cluster tool recognition feature, and how to implement this into your perforated pattern design. Please note that this feature is only beneficial for those who will manufacture the perforated pattern using CNC Turret Punch Press, such as CNC Amada Turret Punch. If you want to use CNC laser machine, this feature will not be useful. Here is a sample of a cluster tool. In this picture, it's showing the die and the tool punch guide of the cluster tool punch. And this is the turret system that hold all the tools during the manufacturing process. A cluster tool normally consists of an array of similar punch tools, where they have a similar distance from center to center in particular direction. From this picture, it is an array of 2x4. The purposes of cluster tool for CNC turret punch are to eliminate the tool hits during the manufacturing process, especially when producing perforated holes sheet that have a massive number of holes. Because of less tool hits, the time required to complete the job will also be less, and intuitively cheaper. Also, the other main purposes of this cluster punch are to minimize the sheet distortion and keeping the perforated sheet has less bowing effect. Let's now start and run Image2Punch Pro. Then, open an existing image called My Shape. This image simple and will be used for this tutorial. Then, let's click the Tooling tab to configure the tooling setup and others parameters for the perforated pattern design. As the manufacturing process will be using turret punch machine, it is logical if we will be using the punch mode tooling. From the tool selection group, please ensure that it is in the punch mode tooling. Then, the next step is to select the tool that will be used to generate the perforated pattern by clicking the Select Tool button. A dialog box will open, and if there are some existing selected tools, we can remove all of them before adding the tools that we want to use. After that, we can now select 3 round tools. They are 6 mm, then 10 mm, and 12 mm. Close the dialog as soon as you assign the tool in the selected tool dialog box. For a side note, I have created all these tools beforehand. If these tools are not exist in your tool library, you can create them by clicking the round tool database library. After that, you can resume the video tutorial. Now, let's click the minimum gap or clearance button. Then specify 3 mm as for the minimum gap. After that, let's open the perforated pattern type dialog box by clicking the button. When the dialog box pop up, click the rectangle tab as we want to use rectangular pattern. Ensure that the tool offset parameter is in 0 offset by clicking the button. Then ensure the inclination is 0 as well. Then the ratio will be 1. For the tool rotation parameter, please select the option 1. From this setup, the pattern will be square pattern where the distance from center to center in X and Y direction will be equal. Click OK to close the dialog box. Now, it is the time to set up or configure the cluster tool that we want to use. For this tutorial, we want to eliminate the tool hits for the 12 mm round tool. First of all, we need to calculate the distance from center to center. This distance are calculated based on the diameter maximum plus the minimum gap or clearance. From the calculation, it will be 12 mm plus 3 mm, which is 15 mm. Let's use and create 3x3 cluster tool. The tool database button for this cluster tool is on the second button in cluster tool group. Then click Add, and a new default tool is created for us. Then, name it as My Cluster Tool A. Set up the diameter as 12 mm. Because we are using square pattern, the width and the height of the array will be the same. We specify 15 mm. Let's change the tool color to red. Leave other parameter as default. Then click Apply to save the new tool into the tool database library. Then click Close. Now we have the cluster tool that we want in the system. Now we need to assign the cluster tool by clicking the Cluster Tool Recognition button. When the Cluster Recognition dialog box opens, we click the Select Cluster Tool button. Then, the Tool Selection button pop up. From here, we need to find the cluster tool type 3x3 group. When we find it, we highlight the cluster tutorial and double-click to select it. Then we can see the cluster tool name appear on the highlighted button. However, when we click the top button and then it became highlighted, this means that we want to turn off the cluster tool recognition. Below the buttons, we can find the cluster tool Optionalizations. This feature is to allow the algorithm to divide the calculation into few segments in order to speed up the computation. This feature is really useful for a very large perforated pattern. However, if only for small or medium project, we can always specify as one for horizontal and vertical segmentation. Now, we click OK to close the dialog box. Now we need to ensure that the pattern viewing will be in color that reflect the tool color. Please select the third pattern viewing option. Let's specify the sheet size to be 1500 mm by 1500 mm. Then the border will be 10 mm all around. Also let's use the proportional mode. For all other parameters, we just leave it as is. Then please click Generate button. As soon as the pattern is generated, we can see that the tool in red color is the cluster tool that has been used to replace all the ordinary tool. Let's now we turn off the cluster tool recognition. Then click OK and generate the pattern again. From here, we can see all the tool is in black. This is because we specify the color as black in the tool database. Let's click the Pattern Report button. And we can see that the total tool hits is 7,252 times. Let's now we use the recognition feature again by selecting the cluster tool. Let's click the Generate button. And you can see that there are some area where the tool is in red color, which is the cluster tool. Let's open the pattern report again. From here, you can see that the tool hit is reduced to only 3,716 times from 7,252, which means that there are 3,536 tool hits that has been eliminated because they have been replaced by the cluster tool. Now let we save the perforated pattern into a DXF file. Before we doing that, let's open the Setting Preference dialog box. In this setting preference, we want to enable or want to check the box of the parameters that related to the cluster tooling. First we need to enable Cluster Tool Center. This Cluster Tool Center is a very important as it will store the location for each cluster tool. This location will be used to place the cluster tool in the CAM software. Second, we need to ensure that the layer system is also enabled. This layering system will be so useful as it will store each tool in separate layer including the cluster tool, the cluster tool center point and so on. The third one is to enable the tool hits color. This feature will create a layer in the DXF with the original color of a particular tool. In this tutorial, the cluster tool is in red. Therefore, the layer that hold this cluster tool will represent the geometry in red color. After we checked all these three boxes, we can click OK to close the dialog box. Then, we can save the pattern as a DXF file. And let's call it as my DXF1. When you open the DXF file in a CAD software, you can see that the pattern is similar to the pattern we see in Image2Punch. And all in the red color are represent the cluster tools. Let's now, we open the layer drop-down. And we can see that there are many layers that represent each tools and other attribute geometry. The layer 0 is to keep the geometry of the sheet size as well as its effective area of perforated sheet. Then, the point layer is to store the center point for each tool. The cluster and tool center is to store the circle shape that represent the cluster tool. The size of this circle is defined at the time we create the cluster tool in the tool library. So, when the DXF is used as the geometry layout when generating the machine program, this circle will be substituted and replaced programmatically with the cluster tool data in the CAM software. The rest of the layers are to represent each tool that has been used in generating me this DXF file. And the one is in red color, is the cluster tool. Because of they are kept in separate layer, we can hide or show as I am doing now. The cluster recognition feature is not only for rectangular pattern type. We can also implement this feature to angular pattern type. The most common angle pattern that many people use is 30, 45, and 60-degree angle pattern. There are two predefined cluster tools that you can specifically use for angle patterns. They are cluster staggered horizontal and cluster staggered vertical. Both of them is in an array of 2 by 3. There are also cluster tools that can be used in either angle and rectangular pattern. They are a single array of 4 tools either in horizontal or in vertical direction. Now let's configure the angle pattern. Open the pattern type dialog box and select the angle pattern type. Let's use a 60-degree pattern type. Then, we use the same tools arrangement as previous pattern, which is round 6, 10, and 12 mm. We also use 3 mm as the minimum gap. From here, we can get the basic pattern calculation with this configuration. The minimum gaps between the largest tools are maintained at 3 mm with the tolerance of 0.0001 unit measurement. In this tutorial, we use millimeter. The angle pattern is at 60 degree when calculate to the adjacent hole pattern. With all these numbers, we can then calculate the center to center between the tools, which is 15 mm with minimum gap of 3 mm. In vertical direction the distance is 12.9904 mm and in the horizontal direction is 15 mm. Then the total different distance between one hole in a row and another hole in another row will be 7.5 mm. Therefore, the offset in one direction will 7.5 divided by 2, which will be 3.75 mm. Having known all these parameters, let's create a tool based on this information. Let's open the staggered horizontal tool. Then click Add to create a new tool. Let's name it as Horizontal Zigzag Tool. Type 12 for the diameter, 15 for the width and 12.9904 for the height. For the offset, we just type it as 3.75. The offset can be in negative or in positive value depending on what the zigzag direction that you want. For this tutorial, we just leave it as in the positive value. For the color, let's select blue. For the tool center position, we specify as 1.25 for the diameter in millimeter. Then click Apply to save the tool in the tool database system. And click Close. Then we click the Cluster Tool Recognition button to define the tool. Click the second button to replace or change the tool. Then double-click to select the Horizontal Zigzag tool in the Cluster Tool Staggered Horizontal. Now we can see that the Cluster tool has been defined. For optimization, let's select 3 for both horizontal and vertical segmentation. Then click OK. Then click the Generate button and we can now see that the blue color tools are the cluster tool that has been used to replace the single tools. Now, let's change the segmentation to 1 for both horizontal and the vertical. Then click, and generate again. And we can now see that the black tools in the blue area has been minimized or changing as the result of segmentation. Let's now create a single array cluster tool in horizontal direction. Although the pattern is an angle pattern, as long as the cluster tool can match the angle pattern, the tool recognition can work as well. Let's click the tool library for single array in horizontal direction. This cluster tool consists of 4 tools that is arranged in horizontal direction. Let's define 12 for the diameter. Then height, or center to center distance between the tool will be 15 mm. Then, for the tool center, let's use 1.33 mm. And select green for the cluster tool color. Now let's open the cluster tool recognition button and change the cluster tool to this tool. Let's click the generate button and we can see that the green color tool are all the cluster tools that has been used to replace some tools in this pattern. Hence the tool hits are becoming less. How about if we want to use a custom cluster tool? This can also be done and the recognition will work as long as the custom cluster tool has some matching pattern with the perforated pattern. In this case the perforated pattern basic measurement are 12 mm diameter, 15 mm gap between center to center in horizontal direction, 12.9904 mm in vertical direction and a total offset in horizontal direction of 7.5 mm. As long as the cluster tool can match this, the recognition will work. Let's say we have a custom cluster tool as illustration. This tool consists of 6 round tool of 12 mm diameter. It is arranged in 60-degree pattern and has center to center distance of 15 mm and 12.9904 mm in horizontal and vertical respectively. The total offset is also 7.5 mm. Let's now we import the DXF file into Image2Punch. The DXF name is Honeycomb Cluster Tool. First, let's click the Custom Tool button. Then, click Add, to add a new custom tool. Then we select the DXF file and click OK. Let's select orange as the tool color. Also we specify the tool center to be 1.1 mm. Then click OK, and click Apply to save into the system. And click Close to close the dialog box. Let's click the Cluster Tool Recognition button and select the custom cluster tool to be used for the recognition. Then click the Generate button, and we can see that all the tools in the orange color are the custom cluster tool that has been used for replace the single tools. Let's set the segmentation to 3 by 3 for both direction. And we can see that the effect of the cluster recognition influenced by the segmentation features. When we open the pattern report, we can see that the total tools that has been eliminated by this custom cluster tool. This will reduce the manufacturing time for this pattern. Now, when you want to use the DXF as the tooling layout in CAM software, all the custom cluster tools as this illustration needs to be hide or deleted. So when you open in the CAM software, the DXF should only consist of the tool center, the custom cluster where this information will be replaced or substitute to the correct cluster tool during the machine programming process. This is the end of the video. I am hoping this will provide you a good information.